This is Mrs. Cribb, and because we didn't get as far as I had hoped in class, we're going to go ahead and cover compounds and the mole in this video. And I'm going to start off by doing the seat practice from the previous section just as a review and to make sure we have this. So how many atoms? So remember, particles can be atoms or molecules or protons or formula units, anything. Particles is a general term for things we're going to count. So how many atoms are in 40.1 milligrams of mercury? So we're going to be turning an atom count or particle count into moles. And remember that moles is my center unit. We can turn mass into moles, and we can turn moles into particles. And this is part of the pathway. Here, mass to moles, moles to particles. In order to go from mass to moles, we have to use the molar mass, mm. And remember, that's the mass of 1 mole of something. And to go from moles to particles, we have to use Avogadro's number. Okay, we went over this before, so just keep this in mind. So this is the pathway we're going to follow. You can go both directions. So here we have atoms. So this is the question. And we're starting off with 40.1 milligrams. Well, 40.1 milligrams is a mass unit. But our molar mass, remember that molar mass is in grams. So I need to use the molar mass for this question, but molar mass is in grams. So I'm going to have to convert milligrams to grams first. So 40.1 milligrams mercury is Hg. And I have to convert it to grams first. So I'm going to use a conversion factor. So there are 1,000 milligrams in 1 gram. That's my conversion factor. So milligrams and milligrams cancel. And now everything's in grams. And now I'm going to use the molar mass because I'm at the mass. The mass is in grams. So I have to turn it into grams first. Now I'll turn the grams into moles using the molar mass of mercury. So since grams are here at the top, I need to put grams at the bottom and 1 mole at the top. Because my goal is to turn it into moles. Whatever you're turning it into is going to be at the top. But I need to know the molar mass of mercury. So I'm going to go look on the internet. I think I have a site up there. It is mercury. There's mercury. And you can see that the molar mass of mercury is loading the element. I didn't really need all that. Is 200.59. This is what it looks like. 200.59. We're going to use 2 decimal places. So if I just go over here, say 200.59 grams. Okay? So 200.59 grams. That's the molar mass of mercury. I'm going to put mm down here because that's what I'm using, the molar mass. I probably should have put it over here just so it's not crammed so much. Now that's going to get us from moles because grams are going to cancel numerator, denominator. Notice that the thing on here is usually in the bottom on the next step. And so now I've gotten to moles. I just went from here, milligrams to grams, and now from grams to moles. I used the molar mass of mercury. Now I'm going to go from moles to particle count. In this case, our particles are called atoms. And I'm going to use Avogadro's number. Okay? So I'm using Avogadro's number in this next step. 1 mole goes on the bottom, and Avogadro's number is 6.022 times 10 to the 23rd in atoms. This is also a conversion factor that you're using by that relationship. Remember, in conversion factors, like for instance, 6.022 times 10 to the 23rd things of any kind, things or particles, equals 1 mole of things. This is the relationship, and from that you write 2 different conversion factors over 1 mole, or 1 mole over 6.022 times 10 to the 23rd. It's the same thing with the molar mass. Over here, when we use the molar mass in this area, I could have written 1 mole is 200.59 grams, because that's for just mercury. That's the relationship. That's how much 1 mole weighs. Or I could have written 200.59 grams of mercury is the same thing as the mass of that 1 mole. Two different conversion factors. Okay, now I'm going to cancel out moles, and my answer would be in atoms, and that's what I wanted, atoms. So now I'm going to pull out my calculator and do this for you. Please follow along carefully on the calculator. All right, it's 40.1 divided by 1,000. Because you can see right over here, it's on the bottom, so I'm going to divide by 1,000. And then the next step, it's also on the bottom, so I'm going to divide again, and this time by 200.59. But now the next number is on the top, so I have to multiply by that number. So times, and I'm going to put it in using the second function, 6.022. Second function, there's that second function. Notice I didn't say times the second function, just second function. There's the double E where the comma is, and then I'm going to put the 23 straight in. That's the exponent. Enter. So 1.2038 times 10 to the 20th. So 1.2038 times 10 to the 20th. Now we got to check for sig figs. The first number has 3 significant digits, so I need 3 significant digits, 1, 2, 3. So it's 1.20 times 10 to the 20th atoms of mercury, Hg. That's the answer for that one. All right, let's do this next one. How many grams? So the question now is mass. So I'm going to erase this portion right here so that we can figure out where we're going to go this time. And this is a good exercise for you to do to work out the pathway. So how many grams, we're going here, are in 9.15 times 10 to the 23rd atoms of calcium. So the particle count is still is still atoms, but this time we know how many atoms we have. So we'll erase the question mark, and we're going to go the opposite direction. We have 9.15 times 10 to the 23rd. So to go from here to here, I'm going to need Avogadro's number. So 9.15 times 10 to the 23rd atoms of calcium, Ca. I got to get rid of the atoms. I want moles. I'm going to moles, so the moles are going to be on top. 1 mole. The atoms are going to cancel. How many things, we're using Avogadro's number, are in 1 mole? 6.022 times 10 to the 23rd atoms. Now your atoms cancel, and I'm on to the next step. I'm turning it into mass, and I'm going to use the molar mass. This time I need the molar mass of calcium, because that's what I'm using over here. These are calcium atoms. So 1 mole, so 1 mole goes on the bottom. And how many grams of calcium is 1 mole of calcium? So we go back and we look at the periodic table, find calcium, there it is, and you can see the molar mass of calcium is 40.08. 40.08. So I'm going to put it back over here, 40.08 grams, and now moles cancel, and I'm going to pull up my calculator and do the math. Alright, so 9.15, it's the scientific notation, so second function, double E, 23. Alright, now I'm going to divide it by Avogadro's number, 6.022. Second function, right here, double E, right there, 23. And then I'm going to multiply it because it's on the top, times 40.08, and get my answer, 60.898. Notice there's no E, 60.898. Now I'm going to look at significant figures. They come from this portion. 3 significant digits, 1, 2, 3. The 8 looks at the 9. It causes the 8 to round up to a 9. 60.9 grams of calcium. So if I had that many atoms, 9.15 times 10 to the 23rd atoms, it would be the same as 60.9 grams. Okay, that's the two problems there. Let's go on to compounds and the mole. And you need this in order to finish that worksheet and plus to be able to move on to the next thing. So compounds contain two or more bonded atoms that behave as one unit. The masses of these compounds can be found by adding up the masses of all the atoms within the compound. So you're going to add up all the atoms in the compound to figure out how much one compound weighs. The mass of a mole of compounds is found in the same way. So this is not that bad. So first we have the molar mass of sulfuric acid, and this is one you should know. Now remember adic-itis? So sulfuric came from sulfate. So sulfate, so I'm going to write all this down. Sulfuric came from sulfate, and then you have to look up what is sulfate. It's SO4, and SO4 has a -2 charge. You found this on the polyatomic ion chart, and so to make it the proper acid, there's 2 negatives, so I need 2 hydrogens. H2SO4 is sulfuric acid. You should have this, you should know this by now. If you don't, you need to review that part from chapter 8. So I don't know what I'm writing there. H2SO4, I need to know the molar mass of H2SO4. So you're going to also need to remember how to count atoms. And remember, I want you to do this exactly like I'm doing it. So in this molecule, I have hydrogen atoms, sulfur atoms, and oxygen atoms. And there are 2 hydrogen atoms, there's 1 sulfur atom, and 4 oxygen atoms. All right, so this is just counting how many there are. Now I'm going to multiply each one of these guys by their molar mass. So I need to know the molar mass of hydrogen. So I go back and look. Hydrogen's right here. We're rounding to 2 decimal places. So that becomes 1.01. The molar mass of hydrogen is 1.01. What about sulfur? I go back to the periodic chart. Look up sulfur. There it is. There's sulfur, 32.06. That's the molar mass of sulfur. And the molar mass of oxygen, look back on the periodic chart. 1 mole of oxygen is, well, this says 15.999, but we're round to 2 decimal places, so it's 16.00 grams. 16.00. All right, now we multiply those two. So 2 times 1.01 is 2.02. 1 times 32.06 is 32.06. 4 times 16 is 64.00. You must maintain the decimal values there. You need to write it exactly like I write it, and there's going to be a reason when we get to percent composition you'll see. So these are the parts. This is the total mass of each of the hydrogen atoms in sulfuric acid, the total mass of sulfur in sulfuric acid, and the total mass of oxygen in sulfuric acid. To get the molar mass, we just add all of these together. So let's see, 4 and 4 is 8, and 6 and 3 is 9. So it's 98.08 grams in every 1 mole. So 1 mole of sulfuric acid weighs 98.08 grams. This is the molar mass, or MM, of H2SO4 of sulfuric acid. All right, now we're going to find the molar mass of aluminum sulfate. So I got to first write the formula for aluminum sulfate. There's aluminum sulfate SO4. We just, right there. It's a -2 charge, and then we need aluminum's oxidation number. So I'm going to have to look that up. Hold on. Right, I looked it up, and it's a +3. Now you can get these numbers off your oxidation chart or your polyatomic ion chart. Put the charges on the top, swap and drop. So this becomes a 2. Put this monster in its cage, bring down the 3, and this is aluminum sulfate. You need to remember how to do this. Now we're going to find the molar mass. We got to count the atoms. We have aluminum atoms, sulfur, and oxygen. We have to separate them all. We have 2 aluminum atoms. We have 3 times 1, so 3 sulfur atoms, and 3 times 4, 12 oxygen atoms. So you need to remember how to count the atoms. We're going to multiply them by their molar mass. We get the molar masses of each atom type off the periodic table. So the molar mass of oxygen is 16. I know because I have it right here. The molar mass of sulfur is 32.06. I already looked it up off the periodic table. It's right there. So I just need the molar mass of aluminum. And so let me go back to my periodic table. There it is. Aluminum is 26.98. Molar mass of aluminum is 26.98. Okay. Now you multiply them by, all. I'm going to pause the video and go ahead. I multiplied them all. Now you'll notice that I'm keeping the zeros here. You don't just write 192. That would be incorrect. You have to keep the significant figures here. So we're going to add all of those together to get the total molar mass. So 53.96 plus 96.18 plus 192.00 is 342.14 grams per mole. That's the molar mass of aluminum sulfate. All right, find the molar mass of magnesium nitrate. Okay, again, we got to figure out how to write it. Magnesium, nitrate's NO3. NO3 is a -1. Magnesium, I think, is a +2, but I'm going to check. There's magnesium. Yep, excuse me, +2, because it's in column 2, has 2 valence electrons that it's going to lose. So magnesium is a +2. Nitrate's a -1. So swap and drop. So put this monster in the cage and bring down the 2. That's magnesium nitrate. Now we need to find the molar mass. We list every atom type. We have magnesiums, nitrogens, and oxygens. We're going to count them. We have 1 atom of magnesium. We have 2 atoms of nitrogen. And we have 2 times 3, 6 atoms of oxygen. Now we're going to multiply them by their molar masses. The molar mass of oxygen is 16.00 grams per mole. You could write it out like that if you want to show the molar mass. The molar mass of nitrogen is 14.01 grams per mole. And we did that in class, plus it's on the periodic chart. Magnesium, I don't know. I'm going to go back and look. Magnesium, 24.31, because the 5 causes the 0 to round up. See, nitrogen is 14.01. So 24.31 for magnesium. So 24.31 grams per mole. Now I'm going to multiply it. So this is still 24.31 grams per mole. This is 28.02 grams per mole. And this is 6 times 16, which is 96.00 grams per mole. Add it all together to get the molar mass. 24.31 plus 28.02 plus 96.00 is 148.33 grams per mole. So that's 148.33 grams are in 1 mole. And this is for magnesium nitrate. 1 mole of magnesium nitrate. Okay, this is one way to write it. You could also write, magnesium nitrate up here. You could flip them upside down. Okay, that's the end of this portion. You need to make sure you know how to do this in order to complete your part of your homework and then to move forward. All right, I'll see you soon.